All right, just to make sure the last video caught this. So Venus's diameter, when you do this calculation, turns out to be 12,000 kilometers. All right, moving on to problem number 7, which is really the last one I'm going to do. Problem 8 and problem 9 are just estimations. I'm not going to bother with those two. Well, 8, the answer turns out to be it's about 1 degree. Your thumb at arm's length. So, all right. Anyhow, getting back to this. So this is the same equation that we used for problem number 6. If you know the distance to the moon, which is 384,000 kilometers, and you know the distance to the sun, which is 150 million kilometers. All right, so yeah. Anyhow, so to do this problem, you just take the diameter of the sun divided by the diameter of the moon. Okay, and so let me see what the problem. The problem says if both have the same angular size as seen from the Earth, how many times larger than the moon is the sun? So calculating this, the diameter of the sun divided by the diameter of the moon, will give us the number of times that the sun is bigger than the moon. Of course, it's a lot bigger than the moon. And so let me scroll down just a little bit. So remember, the equation for distance has to do with the following. You take pi times the distance to the object times the angular size of the object divided by 180. All right, so what we're doing is we're dividing both of those things by each other. Okay, so we're dividing the diameter of the expression for the diameter of the sun divided by the expression for the diameter of the moon. Now, see, since they're both the same angular size, all right, so it turns out that they're both about half a degree in size as seen from the Earth. So since they're both the same angular size, in this equation, these two cancel out, right? The angular size cancels out. And of course, pi cancels out because you have pi in the numerator and the denominator. The 180, of course, cancels out as well. And so what you get is the diameter of the sun divided by the diameter of the moon is simply the distance to the sun divided by the distance to the moon, just because they're the exact same size. All right, and so since we know both of those values, we're going to go ahead and calculate that. All right, so the diameter of the sun to the diameter of the moon is going to be, remember, all those other things canceled, so I'm going to write it in scientific notation to make my life a little bit simpler. The distance to the sun is 1.5 times 10 to the 8th kilometers. That's okay. Divided by the distance to the moon, turns out to be 3.84. That's supposed to be an 8. Times 10 to the, 5th. And notice they're both in kilometers, right? So the kilometers cancel. And so the size of the sun to the size of the moon, when you do this calculation, it turns out that the sun is 390.6 times the size of the moon. All right. So if you took the size of the moon and you multiplied it by 390.6, you'd get to the size of the sun. All right. And remember, problem 8. I'm not really gonna. I mean, I kind of did that one. Problem 8. The reason I know this, if you can practice this sometimes, you wait until there's a full moon, and if you hold your thumb at arm's length in front of the full moon, your thumb will cover up. Basically, it's the size of 2 full moons, and so the full moon is about 1/2 of a degree, right? 1/2 of a degree. So 2 full moons, of course, would be 1 degree. All right, that's it for the problems. Please use these problems to work on the homework problems.